Well, hello friends, and welcome to the April 2024 SerenityOS update video. Andreas has been hard at work on some Ladybird stuff and some other stuff that's still in planning this month, so he asked me to go over these SerenityOS changes. So without any further ado, let's get started. The first thing I wanted to take a look at is a change to hex editor, which is going to need a file to look at. So let's look at, there's no pictures in here. Let's look at a JSON file here from the presenter application. So here in the hex editor, we can see that we have our offset from the beginning of the file here. And there's a little sidebar on the left. So something that Sam has been working on is, I believe, the past couple months he's been adding little quality of life improvements to this app. And the one he did this month is that we can now hide the offset column here, in case that's not information that you need. But also the format can now be changed from hexadecimal to decimals now. Instead of whatever 256 is in hex, hex 100, we can see 256 here. So, yeah, if you're wanting to poke around in files and their binary representation, that might be useful to have decimal offsets here. All right. So the next thing I wanted to take a look at is a little bit hard to show, but if we have a C++ file, you know, we got something going on, like hello world, and we wanted to have a thread local variable. If you're in C, then you can declare it as an __ thread variable. And this is something that requires some compiler support, but it also requires some dynamic loader support, given that we use shared libraries and such. And things like Erno, the POSIX global error variable, are thread local in our implementation. It's something that we've needed to support for quite some time since we added dynamic shared library support. So now, let's see how to explain this. So it used to be before Sonka's patches this month, how do I show this? So in yes, preview for later demo. If we look at the sections for, that's not what I wanted. Yes. If we look at the program headers for bin ls, oh, come on. Uh-oh. Didn't like that, did it? Well, it wouldn't be an update video without something crashing. Let's try this again. Elf L bin ls. Come on. Alright. Look at this guy. Oh god, it's gonna crash again, isn't it? Alright. Jeez. Look at this program header. We've got a whole bunch of segments that get loaded into memory, including, I assume, let's look at libc. This libc should actually, there we go. So libc has these tdata and tbss sections that need loaded, and it has this tls program header here, which means that when we load this library with the dynamic loader, there's some thread local data, namely, let's see, Erno and, gosh, why is this not in wide format? Thank you. How big is this? Yeah, 12 bytes. So we got like 4 ints of thread local data here, like cache tid for get tid and Erno and probably something else. So we load this in, we need to store an image of the thread local storage here. And before the patch by Sonke this month, which is what I was trying to say like 5 minutes ago, we would do this by just passing or calling some syscall to the kernel, some custom syscall that said, hey, can you like allocate a region for me and assign it to the architecture specific thread local storage variable. And that worked, but it's really not how any other operating system does it. So the changes that Sonke made this month are to properly support having user space set, well, what's called the thread pointer for most architectures. So for x86, it uses something called variant 2, well, x86 64 anyway. And what this requires is that we still have to call into the kernel to ask it to set the, I believe it's the FS segment register, to point to a per thread local variable. So anytime we create a thread, we also have to say here's where the thread local storage for this thread is, which is a new parameter to our create thread syscall. But now this thread local storage memory is going to be malloced by the dynamic loader instead of allocated as a region in the kernel directly. And what this allows us to do is eventually move to properly supporting the other thread local storage models. Because right now, if we want to use thread local storage, we just have this initial block called it's called initial executable thread local storage. We just have that. We assume it's going to be some random size, and if you start loading in libraries with like DL open or something, eventually you'll run out of thread local storage. So right now we have this initial exec. We're using this new strategy of allocating the memory for thread local storage in user space, and then asking the kernel to assign the thread local storage pointer on x86. But the fun part is that on other architectures like ARM64 and RISC-V 64, the instruction to set the thread pointer model-specific register, I don't remember what it's called, but on x86 it's FS, and on other architectures it's got another name. But those instructions on these RISC architectures is unprivileged, so we don't have to actually do a syscall to set that variable. Right. So to sum all that up, we now have thread local storage being allocated in user space instead of having this kludge from back in the day when everything about loading programs was done in the kernel. Now we do it in user space. All right. Something else that's hard to show is the contributor Hairspace has come back to give us a patch for kernel coverage. So we have this KCOV device, which I don't think I built into this version of the kernel. No, I don't see dev KCOV. But when you enable this flag in our CMake lists, it will instrument the kernel with this coverage-based instrumentation. And Hairspace came back and cleaned this up, made our KCOV device look more reasonable, more like C++, you know, all that kind of stuff, and fixed up some things that had gotten out of date, as it's been about a year or two since he initially added that. So I'm interested to see more patches in that direction, because more work on KCOV means we might actually eventually be able to run the syscaller tool, which I believe is under the Linux kernel organization. It might not be, but I know it's used by the Linux kernel to fuzz their syscall interface and find deadlocks and crashes and all sorts of fun bugs in their syscall handlers. So that will be fun to get working on Serenity. So thanks to Hairspace for working on kernel coverage. Okay, let's see. So there's also been a bunch of FAT32 write support. Let's see, I believe we now have a FAT32 write support in the kernel. So if we mount a file system as FAT32, we can actually read and write to it. That's something that was started by CQNDefine and then finished up by implicit field. Unfortunately, I don't have a real demo for that, but now we can actually read and write, both read and write to FAT32, 16, and FAT12. I'm not sure who's using FAT12 in 2024, but nevertheless, we now have more full support for that file system. So thanks to those guys for fleshing that out. And that should be useful for things like, I believe on a Raspberry Pi, the boot partition is always formatted FAT32. So if you format a disk image with the standard Raspberry Pi utilities, it'll give you a couple hundred megabytes of FAT32, and then your ext4 file system after that. So that should be interesting to see where we can take that in the future. Okay. So something else that was added this month, we have had the screenshot utility called Shot for quite a while. Let's open this in Image Viewer. So now I have this screenshot here of the, of the entire screen. I believe if I zoom in, we can see that this is in fact the entire screen, and it has a couple options. I believe for delay and selecting a region and opening in Pixelpane afterwards and whatever else. So this is super neat, but a little bit hard to use. So now we have a graphical utility called Screenshot. This is something that was added by, well, it started by Cubic Love and then finished up by Circle, last name I believe is their name on GitHub. So now we have a little graphical front end that mirrors these options. It looks like it's missing a couple. Might be a good patch for someone, but yeah, now we can do the same screenshot selection that you can with the command line utility. Instead of doing that with shot utility, it's done with screenshot. So very cool stuff there. All right, what was next? I believe, yes. So now we are ready to move on to the next stage here, which is going to need me to close this. And there has been a ton of support on the RISC-V 64 port of Serenity. So this has been, it's been in the works for maybe 6 months now, honestly, though it doesn't quite feel like it's been that long. This month, one second. All right. Goodness, this has been in the works, and this month it's been a lot of work by Sonke and Idan, some assistance by Liav, and some patches from Filmrochen and Leon that have been pulled in. But yeah, this is quite slow. But as we can see, we're booting the OpenSBI firmware here in QEMU. We've got, I don't know, a bunch of options on the RISC-V ISA. Mostly just killing time here because this takes a hot minute to load. But we can see that we are on RISC-V 64. Something that Idan did towards the end of the month is he got networking working. And we can see that we were successful in pinging google.com. And I believe that getting interrupts to work with the default QEMU RISC-V interrupt controller has been something that Idan did this month as well. And it boots to graphical user interface, which is pretty exciting. It took, well, as you can see, I'm avoiding actually trying to use my mouse and keyboard here because, well, we don't have a mouse and keyboard driver for this thing. So, big thanks to all those guys for getting this booting. I know that it's been quite a long journey, and we've got quite a series of kernel and user space patches to make this happen. But yeah, and a large part of this has been work by Leon to get our device tree support working better, because we used to just have this ability to parse the device tree, and you would access a fixed path, and we could give you a device tree node for that. But actually making that work with dynamic paths and actually building a tree at runtime and letting you access p handles that point to different nodes has been quite a journey, and we've got quite a few uses of the new device tree APIs and the RISC-V boot stuff, so it's awesome to see. And I think with this, our RISC-V support is now basically at the exact same place that our ARM64 support is, which is that we can boot to graphical user interface, but we can't actually interact with the system very much. So I think there's still some drivers for a RISC-V common USB controller that needs to happen before we can use USB keyboard and mouse. Same thing for ARMS for AR64 for Raspberry Pi. So there's still quite a lot of interesting work to do to bring this up on the two alternative architectures that folks are working on. And personally, I don't particularly care which one gets further first. It'd be interesting to race them and see who crosses the finish line first to an actual usable system. I know that for the ARM64 support, it would be really nice to be able to run on Apple Silicon with hardware acceleration, but that's something that needs, instead of a Raspberry Pi model, we would need to support the QEMU generic model, which needs parsing the device tree, and now that we've got all this work from RISC-V, that should be a lot easier. So some good-looking things in the future for our RISC ports. All right, a couple other things before we close this out here. I feel like I've been rambling quite a bit, but we have bumped our Clang toolchain up to Clang version 18, which came out either in February or March. It's been a little bit ago. They've had 4 patch releases by now. So we skipped the Clang 17 bump because I thought we would upstream our patches to LLVM, but that didn't quite pan out. So Implicit Field did a bunch of the work for the Clang 17 bump. There were a couple of changes to our patches that needed to happen. But then Dan Shaders and Daniel have been, They did help to update those to Clang trunk, and around the time of the Clang 18 branch, and we merged that this month. So now, when you boot Serenity with Clang, we're using Clang 18, I believe. Yes, and as part of that, now that we're using Clang 18 and GCC 12 or GCC 13, we're using GCC 13. So the latest versions of both compilers. So now we've bumped that in our Linux CI as well. So now all of our CI, whether it's for Serenity or for Linux or for macOS, we're using GCC 13 or Clang 18, and that actually had a bunch of speed improvements over the older versions on our C++20 code. So that's been good. We've also had a couple more CI changes. This is mostly myself and Tim Flynn and Tim Schumi, but I noticed early April that that GitHub enabled KVM for GitHub Actions, so we can actually run hardware accelerated in our CI, and that took our test runs in CI on Serenity, built with GCC in GitHub Actions, the test stage from 13 minutes to 3 minutes, which is that's just fantastic. So, and when we combine that with some work by Tim Schumi on making our C cache smaller by limiting it to just limiting the cache that we push to just the artifacts that we just touched with this most recent CI run, that has reduced our CI usage from 10 gigabytes for all the ones running at GitHub Actions to 2. And since it's critical for our CI performance to actually have these caches, it should now be possible to move our Azure pipelines over to GitHub Actions and drastically reduce our CI times, because that's been the biggest pain point, is that the Azure runners that are the free tier by Microsoft are significantly worse now than the free tier from GitHub. So GitHub is offering better things at the free tier. So I think we should be getting away from those 2-hour CI times and get closer to the... Well, it'd be nice to be 5 minutes, but I think we might be able to hit 30 minutes for most PR runs, which would be a significant improvement. All right. Oh, yes, and as part of working on upgrading our compilers, Daniel and Ali and Dan Shaders have been finding bugs in GCC and Clang trunk. So we've been reporting those bugs upstream, and I think we've had a relatively positive experience reporting those compiler bugs, especially with the GCC trunk. They actually fixed one of those within like 2 days, which was quite impressive. So, all right, that is everything I wanted to highlight this month for SerenityOS's updates. Not too much flashy stuff, but there's been a lot of kernel work. There's been a lot of runtimes work in the dynamic loader. I forgot to mention it, but Dan Shaders has been refactoring some things to try to... Well, I can talk about this all day, but there's been some refactors in the dynamic loader and libelf as well. We've got some kcuff stuff coming up. We've got more file system stuff going in. All in all, I think it's been a pretty quiet month, but there's a lot of interesting things with related to alternative architectures that should be coming down the pipe soon. So with that, I think you've probably suffered my ramblings enough. So thanks for watching, and hopefully we'll see you again next month. Bye.